I hope you have been thorough with the singly linked list. So now we'll see a doubly linked list. So before starting in depth with doubly linked list concepts, so let's just sharpen the concept of linked list. So linked list is mainly to implement. Actually, linked list is a linear data structure where which it is used to implement the list in dynamic nature. So when your list memory size is getting grower and grower when your input is getting larger and larger. In that regard, where your memory size is unknown, that is called dynamic. Okay, so when your list size is unknown, so in that regard we use linked list as structure to implement that. Okay, so regarding the linked list, we divide that into three categories. One is singly linked list, doubly linked list, and circular linked list. So this division has been done in terms of information flow. Okay. So here we will see ADT operations. ADT is nothing but abstract data type. The operations, the basic operations which you perform on the linked list is nothing but creation, which involves creating a new node. Once you just created a node, then we do addition, that is inserting the node to extend the list. Okay, so insertion can be happen in the beginning of the list or in the middle of the list or in the end of the list. Okay, same thing. Once you add it, so add will be done whenever you require that node to be in the list. Okay, so deletion is like when after adding it, if you find that that is unused or it is not required, then you will be in the position to delete the node. Okay, deletion also happens in the beginning of the node, middle of the node, and the end of the node. And we have search option, so which requires a searching the particular element. Okay, so we have a list of elements in the linked list. In that case, I need to check whether the given number is already existing or not. In that case, I'll be using a search method to search for that particular element. So we can have some kind of problem where like we'll get a requirement to get this to be number to be inserted in the list if it is not there, because which to avoid duplication, so we need to check the entire list whether that particular element is in the list or not. If it is not there, then we involve in inserting that node. If it is there, we just ignore the insertion part. Okay, that is where we have a search method. And then traversing, which is nothing but to visit all the node and get the element and display those elements. So we'll have requirement that I want to know like how many elements are stored. Okay, I want to know that what are the elements are stored. To get that kind of information, we use a traverse method. Traversing is simply means that displaying the all the informations from the list in the output screen. So these are the ADT operations of linked list. So ADT is nothing but a data definition which without any implementation details. So when you have a normal like the components which you want or not components, okay, whenever you won't have the list of operation that is possible on that particular structure. Okay, but we are not considering about the implementation over there, that is called ADT. Okay, so fine. So these are the operations of linked list, actually doubly linked list, not only for doubly, so for all linked list these are the main operations we use to perform. Okay, so now we'll see the doubly linked list in depth. Okay, so regarding doubly linked list, this video covers only creation. Okay, the next video I'll upload for the insertion part. So regarding doubly linked list to be considered, so this is your representation of doubly linked list. So here is a structure for that. How does it look? As it is doubly, which means that I'll be like able to perform a two-way communication. Two-way communication is nothing but I can able to connect the front node and second node. From second node I can come back to the first node. Okay, so in that regard, the term is called doubly. So where we will be performing two-way communications. So here I can able to navigate from first node to second node, which means that I can travel from in the forward directions. Okay, same way I can able to again I can backtrack and I can forward to the backward directions. That is your two-way communication part. So as it is two-way communication, so in that regard we use two pointers. Okay, as node to be considered, we always should have a data and the pointers to just have to establish a virtual link. That's what we have seen regarding singly linked list. Same way, to establish the virtual link among the scattered data in the memory representation. So, and also we are working at the two-way communication process. So, we require two pointers. Okay. For that, we require the pointer to store the address of the previous node. That pointer is called previous pointer. And then other point is called a next pointer, which is to store the address of the next node. Okay. So, if you see here, this is a kind of picture representation of doubly linked list. So, this is nothing but your previous pointer, and this is nothing but your data, which is in type, and this is a normal variable. Actually, this is a pointer variable. So, this is a pointer variable, okay, and this is your normal variable, and this is your another pointer. Okay. So, another pointer variable, so which stores the address of the next node actually. So, that is why we call it as next pointer. So, this node is pointing to this node actually. Okay. This node will be pointing to this node, and this node will be pointing to this node. Okay. So, here the previous node, this is a pointer which stores the address of the previous node, and this is a pointer which stores the address of the next node. Okay. So, this is how your structure of doubly linked list will be there. So, doubly linked list is a structure of node which takes up three components. One is for previous node, other is for next node, other is for data. Okay. The element which the information which you are going to load in the particular a particular place or a linked list part. So, as we know that the array is a list which stores information only on similar kind of data, okay, only on one type. If my array is of integer type, it takes up only int type, it won't store the float type, it won't store the character type. So, only one type of data I can able to store. But regarding if you take the node actually, we have two different types. One is a pointer type, the other one is nothing but a normal int type, okay, int variable. So, I need to store a pointer and also a normal variable into a same list. In that regard, I prefer a structure which stores a data items of different types. Okay, that is why we use a structure to create a node because of loading a different types of data. So, this is one type and this is other type. Okay. So, the structure, to represent the structure, now I am just delete this, and to represent the structure I will tell you how this code works. Okay. Okay. So, this is where actually, and this I will just recolor it so that I can able to, you can able to understand what is happening, how this particular snippet is working. Okay. So, let me again just come back to this again actually. So, just all these things. So, fine. Okay. So, here to bring this kind of representation, okay, in a picture way, so we have a structure format because of storing a different data type. So, the syntax for creating a structure is struct is a keyword which you have to defaultly use in declaring a structure, and this is a structure tag. This is user defined, you can give any name, and once you open up, so here as we need three components, so we need actually data that is of int type. So, I am just giving int data. So, here I will be having one particular informations regarding data, and we have two pointers, one is for previous node and the other is for to point to the next node. So, in this case this is my structure thing. So, here my node which I want to create should be in this structure. Okay. So, node which I am going to create is should have three components, that is my structure. Okay. Now, I am just entering into the main function. So, where which I am starting with creating a new node now, new empty node. So, new empty node is like, so here when you are just having a node as a pointer, so here I am just creating a structure variable or structure pointer variable. Okay, I am just creating, whenever you create a new node, you have to create a structure pointer. Okay, so when you give like this, then you can just allocate a memory dynamically. So, this is where you used to declare a memory variable dynamically. Okay, so n is equal to, so n is my new node which I am going to create, n is equal to struct node pointer, which means that mlock always returns void pointer. I can able to typecast, or I should able to convert that into a, because void pointer is nothing but it is a flexi pointer where which I can able to convert that into an like whatever pointer, like I can change the type actually. So now I'm just going to change that void pointer to struct pointer. In that regard, I'm giving struct, then add node and then pointer. This pointer I'm going to convert it. Okay. So M block, then inside that I'm just asking the memory representation to allocate a memory size of struct node. Okay. So in this regard, my struct node is a memory size of like we have a structure here, and this takes 3 components. Okay. So here my data of int is nothing but 4 bytes. Again, this is 4 bytes and this is 4 bytes. Totally 12 bytes of memory is taken. So size of 12 bytes of memory, I should be allocate a node actually. Okay, 12 bytes of memory I have to create, that is specifically allocate for a node called n. I'm going to create a node n. So node n is like what I told, I have to create in a struct type. Okay, going to here now. Okay, in this how many components are there? We have 3 components. So I'll just collect 3 components, and then one is for data. I'll just give separate coloring so that you will be understanding it better. So I'll give this in blue color, and 3 components now. One is data, you right? Okay, this is my another thing, and this is also a pointer. I'll just give the same color to make you understand that that is also a same kind of way. Okay, so I have been like, so as structure says that we have 3 components. I have created 3 components now. So this entirely 12 bytes of memory. Okay, so now this is a data. So in between we having data in middle actually, and this is the pointer which takes and store the address of the previous node, and this is the next pointer which takes the address of the next node. So, but regarding mlock, whenever you allocate a memory for a new node, mlock always goes with taking some garbage value. Some garbage value. So, just a starting only. Lady. Matra. Okay. Okay. Next is like we'll be having a garbage value here. So once like the mlock is like allocating a memory dynamically, it allocates initially with the garbage values. Then what our purpose is like, we have to replace that garbage value with new values, not new values, with our values, our own values. But as of now, what I'm going to do is, I'll just, because I don't have any value now, because this is a first and last node, this is the only one node we have in the list. So in that regard, what I'm going to do is, I'm going to replace all the values with null. Okay. So as it is a pointer, we know that the members of the structure can be accessed through pointer in this way. So I'm just mentioning the node name. So node name, okay, what is my node name? N. Then to access that, I'll use arrow mark because it is a pointer, and then I'm just mentioning that the member name. I'm going to mention the member name as data. Okay, I'm just going to assign that as null because I want all the information to be null. Once you give this, and this particular position will be changed to null. I'm replacing all the garbage value with null. Again, I'm just giving this, and I'm taking the previous pointer and I'm assigning with null. Now the previous also converting to null. This is also changed. Next is like we'll be having n, and then we'll be having next, then that is also null. Okay, so I'm replacing this garbage value also null. Okay, now everything is changed to null. This is what I did. Now it is an empty node. This is an empty node. Okay, open up for your values. So whenever I insert a node here, then the virtual link will be established. Then that we have to do actually. Virtual link will be established here, and that can be done. Okay. Now if I want to replace a data here, I just give n data is equal to 10. If I give this, then again this null will be changed to 10. Okay, now only one node is there. Okay, with the value 10. There is no previous node, there is no next node now, which means this is the only node. Okay, in the list. So now we completed the operation of creating a node in a doubly linked list. So I'll just summarize it. As it is doubly, we have to you go with two-way information flow, where which you will be directing to forward direction and backward direction. We use 2 pointers. One is like, as it is two-way communication, we use 2 pointers. One is for previous pointer and the other is the next pointer. The previous pointer is a pointer which point to the previous node. Next pointer is a pointer which points to the next node. And we have the other component called data. So which means that I'll be loading that data into the list. So totally 3 components will be there. As we need a container to store different types of data, so we use structures for that, because array will not store different types of data. In that regard, I just we have been used structure to load different types of data. Next is like in that no, we have just created structure now. We are not creating, this is not to create a node, this is to create a structure of how my node has to be. Okay, this is a structure alone. Okay, this will not create a node. Okay, this will create a node. Okay, once you just create a, this can be like I can create, if I want to create n number of nodes, like I want to create like 3 nodes now, in that regard I can give like this, I can create declare more structured variables. So this is n, and this is a pointer, this is x, and this is pointer y, this is pointer z, like this. Okay, like this I can just create it. Okay, so each thing I can, again what I can do is I can just have like the same concept. So entire concept, this can be again recreated here. I can again give like this, so I can replace this n with 1 minute. I can replace this n with x now. So because this is other node. So here once you create, once you just executed this, then I will be having one more node here. I will be having one more node like this. An empty node is created, and this memory address is say for 500, and this memory say for 1000. Okay, so this is your node n, and this is my node x. Okay, as of now I'll just work with only 2 nodes. Okay, I'll just delete only x. Oh yeah, only this is fine as of now for your understanding. So I have created the x n and x. So again I can just have this working process. So where I have been like initialize the data to 10 now. The same concept you can copy it. Just copy this and just paste it. Okay, paste it, and then this will be like I am just giving it as a 15. So this will be like x. I have to replace this with x because this is x node, and I have to mention that actually. Without mentioning that, then you are changing with n value, you are working with only n, then everything will be only one node you are working with. Okay, so this now we have 2 different nodes. We have node n and we have node x. Okay, here I have 15 now. Okay, now this is like a different thing, but it is considered as a 2 different kind of list, but this is everything in the same list now. Then I have to establish a virtual link. How to establish a virtual link? Okay, what I have to do is I have to mention 1000 over here because I have to store the address of the next node. This is my next node. Okay, so here for this I need 1000 to be given here, only then there will be an establishment of virtual link between these 2 nodes. How to bring the 1000 value to the n next? So what I have to do is I have to go to n next, and I have to give x. X. If I give this, what happens now? Then the x address is 1000. So just take, because x is also a pointer. I can give like this now. Then it takes up the memory address of the x and then the node. Okay. So where which you are working with the next pointer. So here next pointer is like I have the next pointer stores the address of the next. Now we have been generated a virtual link. Okay, and I'll just take the shape. Where is shape? So I couldn't get that symbols. Okay, I'll just draw an arrow mark. Is I can do that. Okay, I'll just draw this. Okay, so where which it is. Okay, where couldn't find the arrow marks. Okay, anyway, you just have a link actually, link between these two. So next is like I need this actually, like I have been given the next address actually for this. Now the thing next address of this, it is getting linked with only forward direction. Then I want to bring the backward direction from this to this. In that case, I have to connect the nodes of previous node of x. I have to say that 500 is my previous node. Okay, the x has to know that the 500 is the previous node. Then I have to store x previous is equal to n. So x previous is equal to n means, which means there is an establishment of backward link. Okay, it has been established from second node to first. Now it is 500. Okay, so we have two nodes. Okay, so in the first node always your previous node will be null, the last node always your next node will be null. This is the case. Okay, this is how you just create, this is how you just create a new nodes. These two statements, this is where you create a node, this is where you represent the structure of a node. Okay, this does not create a new node, but this creates a new node. Okay, this order you have to maintain. You have to first declare the structure of the node, how does the structure should look like, and then create n number of nodes by using the same syntax. And then this has to be established for each and every node. You have to assign the values for three components. One is for data, and the other for previous node, and other for the next node. Where does you want to create a virtual link. Okay, so that's it regarding the creation of doubly linked list. Okay, in the next video we see how to perform the insertion at the beginning of the list. Okay, so thank you, happy learning.